many of the publications and even working as a research supervisor for JN2H Hyderabad, an editorial board member for international peer review journals, and presented 16 papers national and international conference. It's a pleasure to introduce today's speaker, Dr. G. Krishna Kumari.
Yeah. Thank you very much, Shalini, for the nice introduction about me.
Thank you, ma'am.
Okay.
Madam, 1 minute.
Yeah.
1 minute. Your camera is off, madam. Just please
okay.
it on. Again, she will repeat once more because it is not telecasted in YouTube now. Again, we are telecasting itself. So please, once again, she is going to introduce you once again all things about webinar. Yeah, madam.
Yeah, is the camera on?
Yeah, now it is on.
Okay. Okay.
It's a great opportunity to introduce today's speaker, Dr. Krishna Kumari, MSc Applied Mathematics and PhD from Fluid Mechanics and MTech CSE from BITS Bilani. And ma'am has a challenging works as handle like academic administrator with the minimum capacity of associate dean academics and a freshman engineering department with respect to organization growth in a systematic way by implementing various innovative teaching learning methodologies and strategies, which leads to overall development of services. Overall services as professor of mathematics, professor offering applications oriented knowledge to the students with the latest technology and administrative accomplishments like academic administration, vice principal, associate dean, academics at Kale University, Hyderabad. Academic planning, preparing all the necessary documents for the function of the system, and academic accomplishments, 24 years of academic experience, 10 years of research experience, and 8 years as HOD academic administrator. Received Women Excellence Award for the Best Academic Administrator from ILDC and AMP on the occasion of Women's Day in March 2020. And research accomplishment working on a minor research project of worth 1,95,000 sanctioned by UGC in the year 2017. And working as a reviewer of 4 international journals, editorial board member of international peer review journals, and presented 16 papers, national and international conferences, and working as a research supervisor for JN2H Hyderabad, and published 3 books with ISBN numbers, and published 28 papers in peer-reviewed Scoopus Index, UGC recognized international journals. Ma'am, it's a great privilege and it's a great opportunity uh, you to be as a speaker for today, ma'am.
Yeah, thank you, Shalini.
Yes, ma'am. You're welcome, ma'am.
Thank you. Thanks for the nice introduction about me. Thank you. Hello?
Yes, ma'am.
Yeah, am I audible?
Yes, ma'am. It's clear, ma'am.
Okay, fine. Yeah. Dear students, faculty, and all the participants, a very good afternoon. First of all, I would like to thank management, Vignan Institutions, Rataya Garu, Principal Dr. Apparao Garu, and HOD Basic Sciences and Humanities, Dr. Srinivasulu Garu, and all the coordinators of this event for giving me this wonderful opportunity to share few thoughts of mathematics importance in development of science and technology. Usually, students used to have a fear about math because of lack of orientation, counseling, and the approach towards the course. If we give the proper orientation to the student and proper counseling about mathematics, definitely students will not have any fear about that course. And the students, those who opt for engineering or any other degree or PG courses, definitely will have the comfort zone with respect to mathematics. Hello? Hello, am I audible?
Yes. Yes,
Yes,
you
ma'am.
are.
It's clear, ma'am. It's clear.
It's clear? Fine. Okay. Okay, fine. Now, we all of us use math in our daily life, but we never consider it or recognize that or notice it. Now, let us look into the development or the importance of the mathematics in development of technology and engineering, even sciences also. I will share the presentation, start sharing the presentation. Yeah. Hope the presentation is visible. Yeah. Shalini, can you please give me the
Presentation
input?
screen.
Is visible?
No, ma'am. It's not visible, ma'am.
It's not visible. Just a moment.
Yes, ma'am. It's clear.
Now it is visible, right? Fine.
Yes, ma'am.
Yeah. We start with the essence of role of mathematics. Math is an autonomous intellectual discipline. Some noise is there. I don't know. Please mute your mics, all of you. Yeah, fine. One of the clearest exponents of the creative power of human mind. So math is created by we people only. We have to remember that. Other hand, it plays a very important role in science, engineering, and technology also. Now, the first dimension of math is towards pure mathematics, which is an art of its own direction, and this is a game played in our minds also. We can consider an example like supermarkets or any other share market related. All these are only. So, what kind of benefits will be given to the customers, and what kind of benefit the people will get. So this is nothing but a gameplay between the consumers as well as the supermarkets or any other owners. And math is one of the most compelling examples of human capacity of reasoning and analysis. So whenever people think about math, it is a logical course, it is a reasoning course, and this is for that mathematics course, definitely a lot of analytical skills are required. This is the general public opinion. And the important part of math, which is taught in universities, is completely devoted to education of engineers, physicists, chemists, computer scientists, economists, and even other professionals of several disciplines also. But later on, not only the education or not only educating the people and making the people as engineers or physicists or chemists and so on, people identified that tremendous applications are there towards other disciplines like economics, financial market, other branches of chemistry, biology, and medicine, even social sciences also. The only point is we people are unable to identify that particular landmark of mathematics in these all these fields. The capacities of scientific computation made numerical simulations and indispensable. This is an indispensable tool in the design and control of industry processes by applying many mathematics softwares. Now, just we give a glance to math softwares and where exactly what mathematical part is used for it or will be useful for that. Now, example, computer algebra systems. How to systemize the problematic algebraic manipulation tasks. So, systemization is the main point for this computer algebra systems. Now, the second one is axioms, ability to manipulate mathematical expressions for the expectations, towards the expectations of mathematicians and scientists. So, what are their expectations? How to convert their exact problem into their traditional part, and how to do the computations for that. For that axiom is used. And computer algebra system, another part which is the extension. Maxima is the extension to that first one. And GAP, CIR, CA softwares, where computational discrete algebra, computational group theory, these are the main applications for that. And field theory, for that the software is used CAD ABRA. And the other one is computations in commutative algebra, multivariate polynomials, the mathematical part in that. The other things related to our CSC related also there. SciPy Python programming language library. And definitely this is very useful. Graphing program with extensive graphical features. GNU plot, that is the math software which is used, and SPSS and R, naturally statistical tools or which is used for statistical analysis, and Sage Math, which is the alternate for Maple and MATLAB, PARI or GP. And here math parts are number theory, computations, factoring, algebraic number theory, and analysis of elliptic curves. And the other one is SymPy, computer algebra system written in Python, and MATLAB, higher level language. Octave is the which is a duplicate for MATLAB, other alternate I can say. Now in MATLAB, a lot of updates are there, like experiment manager application, and which is used for deep learning, symbolic compiler, live editor task, flexible plot placement. All these are the advancements in MATLAB now. And what is the mathematics role in under sciences or engineering? So the same thing we can consider as math in the hands of scientists and engineers. In the hands of scientists, how math will play. It plays a role of assimilating the data and understanding the phenomena. So based on that, understanding the phenomena, only the research will continue. In the hands of engineer, it is a tool which is used for decisions and designing artifacts, and reliable way, which we call this as applied mathematics. All of us know about this applied math. And also it covers classical areas like mathematical physics, mathematical methods for engineers by using scientific computations and numerical simulations. Next, modeling, computational simulation, and data analysis. These are the very essential tools in engineering and technology industries. Now see how to construct a mathematical model. Usually people always used to say that mathematical modeling, these are the very prominent words we used to hear. Usually, how a scientist or researcher or engineer solve a problem or how they get a solution. First of all, a real life problem or real world problem will be given to the researcher or scientist or an engineer. So what they do first, they define the problem. First of all, they define the problem and they try to convert the real world theoretical problem into the mathematical part. And they do the assumptions, and they find out the variables, they define the variables, they analyze the problem, and they assess the model, and finally they generate the results and report also. For all these sectors, lot of research and lot of brainstorming is required. Now, let me give a very, very small example, which is easily understandable for the students as well as the participants or faculty also. Like faculty, usually we prepare an assessment sheet for any course. Let me suppose 100% is the total weightage. So how to divide this 100% into different categories? Suppose midterm examinations. Let me give a specific percentage for that. Similarly, quiz competitions or assignments or projects or any case studies, a specific percentage, and similar end examinations, a specific percentage. Altogether, the total should be 100%. So what I have to do? First of all, what is my problem? I have to prepare one evaluation or assessment sheet for my particular course. And for that, what are my assumptions? My assumptions are, I am dividing that 100% into these many categories. like 20%, 30%, 40%. Likewise, I do the assumptions. And later on, I define the variables like x1, x2, x3, so on. And the sum of all these variables must be equal to that 100%. And later on, I do the analysis part. So what is my analysis? So how many marks I have to frame for that particular midterm examination? See, first of all, I am fixing the weightage. Later on, I'm going for the marks specification. So that kind of analysis part I do. And later on, I do the assessment for the model. Like I give a specific data and my Excel formulas are correct or not, I recheck. Later on, the total marks are coming, that is the right value I'm getting or not, and the total percent is reaching to the 100% as the denominator part, and the numerator part is also balancing that sheet what I prepared. And finally, I report the results. See, for this, for all these parts, I need definitely some research and brainstorming also. Just like that, I cannot divide the percentages into categories. Some rules and regulations will be there, maybe fixed by my university or might be fixed by UGC or ICTE or any other board. So I need to consider that part. So I have to go for a research in that, and I need to do the brainstorming for that. And finally, I'll come to one conclusion. So for this small, very minute problem, I did all this work. So this is the way I can construct a mathematical model. Now, this mathematical, yeah, hello, any problem?
Madam, your camera is off, madam.
My, what?
Your camera is off, madam.
Camera is off. Oh,
yeah.
Actually, simultaneously both are not coming, I think.
No,
Just
madam.
a moment, I'll check that.
Okay, please check.
Yeah. Yeah, it is showing that you can share your video when you are done screen sharing. So that's a problem, I think. So I'm sharing the screen. No, that is the reason why video is stopped. Okay. Hello. Hello.
Madam, actually, you shared the window screen desktop. No? Then you can easily do it. If it is possible, do it. If not, continue, madam. Yes, madam. Are you getting, madam?
So I'm calling you, I think. Hello. Malikarjun garu.
No, madam.
I'm calling.
Madam, I am calling, madam.
Yeah, I'm calling you. Please pick the phone.
Yes, madam. My phone is not hanged up. Phone చేసి ఇవ్వండి మేడం మేడం ఒక్క నిమిషం మేడం I will 1 second share it madam, you will get, I think so, right? I'm being here only.
Okay,
share it madam. 1 second.
Yeah, sure.
Right. Yeah, you can share madam, only PPT, or you can share desktop also.
Yeah, when I share the desktop, camera automatically is off.
Is off now. Yesterday we got, but now only window, madam. If not shared, only window, that particular PPT window only. Already it is open, na? That only you can share it.
That only I'm sharing now, but I don't know why.
Madam, actually, have you shared desktop or window, madam?
Window only. Previously, desktop I have shared. Okay, now I'm trying to share window.
Okay.
Now check. Even now it is off. You can share your video when you are done screen sharing. It is showing. Remark clearly it is showing.
Yeah, ma'am.
Okay.
Okay.
So we don't have any other option of simultaneous sharing both.
Both sharing is there, madam. That's why I'm asking.
But I don't know why. I'll send the screenshot of that. Please check.
Yeah, madam. Okay.
To your
Just
mobile.
1 second. One second. Share it.
Please
That.
check once. Check once.
Yeah, madam.
You can share your video when you are done screen sharing. That is the remark it is showing.
Okay.
Open your phone. Open your phone. I sent a screenshot.
Yeah.
Please check.
I'm checking. Yeah, it is same. I'm getting the same. Whatever you are when that screenshot, I'm getting same here also, madam. Madam, if not, you can continue, madam. The way you are getting now, because
yeah, fine. Because we don't have another option, I think. Because I've shared even window also. I tried with window also.
Okay, okay.
Even though it is not taking.
Okay, right.
Any other option?
Actually, in sharing, in sharing, you'll get, madam. Actually, screen sharing means desktop, window. Both options are there. Any one you can do it. Now your video is getting.
Yeah, video. I on that because screen sharing is stopped, right?
Yeah.
So now see this window I'm operating, right? Desktop / window is there.
Yeah.
Window automatically it is stopped. Did you check?
Yeah, it is. You are off now.
That's what. That's a problem. I don't know.
Which option? Whether you have taken the desktop or screenshot?
Window only. Window. Can you make a call to me? Just 1 minute. Can you make a call?
I'm calling you.
Yeah. Camera also on.
Madam, yeah, it is. You can continue, madam. It will get afterwards because net problem maybe I think. So you can continue.
Okay. We can't, and both simultaneously we can't.
Yeah, actually the
It's
problem
not
is
getting.
bandwidth problem. So continue, madam.
Don't know. Okay, anyhow, fine.
Yeah. Thank you.
Yeah. Sorry for the interruption because of the technical issue. Fine, we continue now. Um, yeah, once after completion of this mathematical model, now we can come to the mathematical sciences associated areas. So all these areas are associated with mathematical sciences only: medicine, geosciences, communication, finance, engineering, and so on. And even many are also there, especially now because of this COVID. Biology and virology have the prominent roles to solve the existing problem. Now, let us look into math in science, where exactly math is used in examples I would like to quote. One is forensic mechanics, catching a speeding motorist. So, forensic evidence, collision damage, witness statements, and skid marks. All these will be taken as forensic evidence. Now, see here, evidence, cause, other data, and assumptions. Next to symbols, variables, S, U, F, and the related object is distance of skid, speed, brake force. Now, based on this data, people will calculate the mechanics links the speed to the distance. So, these are the known formulae. Physics or math from 8th standard onwards, we are studying all this. So we can calculate the speed of that vehicle. Next, any accident is there. Because of the speed, the accident has been happened, or any other personal reasons are there. That also can be identified. Especially speed related part, this math is useful. And later on other reasons, the forensic lab people or any other investigative people will continue that part. Now here another example is microwave cooking. What gets hotter, outside of the food or the inside? Now you can see the second image, thermal image of surface of food after 5 minutes of heating. Now here you can observe the container is hotter. So the point is, first of all, the container will be heated. Later on, that heat will be transferred to the food items, and then because of the transformation of the heat, the food will become heat or hotter. That is the reason why for different food items, different temperatures will be mentioned while using the microwaves. Suppose before itself, if you take out the food from that microwave, automatically the boundary layers of the food only will be hotter and inside food will not be cooked. And what math is there in this part? So here this L represents domain length and D represents penetration depth. Maxwell's equations for electric fields is used here. And this is the differential equation. Dou T by dou small t is equal to K Txx and so on. And these are the initial conditions. So by using these initial conditions, and we will for a particular item of having so and so length and so depth, to keep that item into microwave. So this is the math behind. One more example, packing and folding of rocks, swallowtail catastrophe curves. That example we are taking. the point x comma y is s minus st by root over 1 plus s square and so on. These two are the parametric equations. And from high school standard onwards, people are studying about the parametric equations, at least in intermediate. Definitely you remember this part, parametric equations. And there is a relation between even and s and t also. And these are the state variables. Now, if you consider a particular point here, what is like how that x comma y point can be generated by using these state variables. So this is the math behind that. So furnitures, hardware for this particular part, or here for this area, all these will be calculated. Now, well-known examples: weather, global warming. Here, you can say this part. Enormous impact. There is an enormous impact on the use of modern math for analyzing the weather, climate changes, and fluctuating the stock market. And this is about this part all of us know. And catastrophe theory helps explain the instabilities. Where exactly the instability is there? Iceberg. 80% of the floating iceberg is hidden below the ocean surface, and the leftover part will be outside. As this part melts, the iceberg can become much instability is there, which sometimes we call it a stability analysis also. And for that, what kind of skills are required? Excellent IT skills and as well as strong skills in analyzing interpretation of the complex data. These are the skills required for this. And one or two more examples: aerodynamics, gene research, understanding the way of air flows around the wing, and to reduce aircraft noise over populated areas. For this is used. So for this, what kind of math is used? What kind of engineering is used? Aerodynamics and part of trigonometry, vector analysis. These are the prominent math part aerodynamics. And now come to gene research. Here, the main math part is used is statistics, even probability also sometimes for the estimations and hypothetical analysis. And for this, new mathematical techniques used to analyze the data. So what kind of data? DNA and genetic human genome project, and even genetic disorders or these kind of for all these kind of gene related, this math is used. One more example is tsunamis, how they form, how they propagate, and how math holds the key to understand this part. And especially if you come to, you consider this wave theory, wave analysis, what is the speed of the wave and how it penetrates. Also, what is the wavelength and absorption capacity and force, how much force the wave is coming out, and what is the pressure. So all these characteristics will be a part of this math. And one more example is here, wave vapor mixes into the eye of the hurricane. Because of that reason only hurricanes will be generated. So understanding of the dynamics of the hurricanes, in that also math is used. Now here if you see how the cream mixes into a stirred cup of coffee. So both are similar. So both processes are described by the same type of mathematics. Now come to engineering part. This is a very simple example. Not only hyperboloid, many examples are there. Hyperbola, parabola, paraboloid, circles, squares, cubes, any are there. And next is coming slides, we will see that part. And the other one more application, math in engineering, is mechanics in undercarriage. Now here you could see tires. So what math is there here? What is the RPM rate, rotations per minute, shock absorber capacity, number of continuous working hours, operation capacity of material of the tires, and life of the tires. So for all these calculations, math is very much useful. Now come to the latest and very interesting areas. You could see kind of Venn diagram here: artificial intelligence, machine learning, deep learning, and data sciences. Here we could see these are the subsets. Deep learning is a subset of this, and machine learning is a subset of artificial intelligence. Data science, partial. Here what math is used? Statistics, linear algebra, calculus, and even probability and probability also. And for programming, data management, software systems, and development operations. So we discuss now the mathematics for artificial intelligence, machine learning, and data science. Here, if you observe, all these four, linear algebra, P&S, optimization, and deep learning, all these are interrelated. A cycle has been formed. Now come to the next one. What are the skills to build a career in artificial intelligence? Now observe this left diagonal. We should have the sound mathematical and algorithmic understanding and efficiency in data sciences, well versed with machine learning. So these are the requirements. One of you, I think your microphone is on. Can you please mute that? Yeah, thank you. So here the first we consider mathematical understanding and algorithmic understanding. Mathematical understanding already in the previous slide we come across like linear algebra, calculus, probability, stat, optimization, all this, and come to this algorithmic understanding. And here those who are aware of design of algorithm and analysis part, we use lot of dynamic programming, and in that the named algorithms are like knapsack algorithm, rod cutting, Huffman coding, and greedy algorithms, breadth first search, and all these are next coming. These are related to graph theory, BFS, DFS algorithm, crucials, prims, distress. All these algorithms definitely will be useful somewhere or other. And efficiency in data sciences, and data sciences definite like in the next coming slide we discussed about that. And later on machine learning. For machine learning also the main important areas are probability and statistics like correlation, regression analysis, and even probability part also are used to upgrade the skills to build the career in artificial intelligence. Now here if you observe this part, math, sociology, computer science, all these parts are there to excel in artificial intelligence, and out of all this math play a prominent role, and math provides means of implementing how their goals can be reached, whether it is AI or machine learning interrelated. Math there in the sense a person, maybe a researcher, maybe engineer, maybe a scientist, to achieve their goals, math will be used as a tool. And here I just would like to mention a point. Always please treat math as a tool for all the areas of science, technology, and engineering. Maths is an autonomous and independent entity, but as it is used in all these areas, it has to be treated as a tool to complete their perspectives or their goals. Now, usually whenever we think about the artificial intelligence, the prominent example, self-driving cars example is to be taken into consideration. So self-driving cars attracted a tremendous interest. Now what is the goal? Our goal is to have computers recognize people and objects as video images. But because of so many reasons, it has not been happened. And finally, people understood a different approach has to be done. And that approach is like considering the highly parallel networks with many simple nodes or layers and adjusting the multitude of weights of the connections. So by considering this part, now lot of improvements are there in that. And finally, we could see nowadays the successful self-driving car. Might not be in our market, but in global market it is there. And math gives a powerful answer in the form of minimization procedures. So one more very important technique what we use is optimization techniques. First of all, minimization. For that minimization part, and for this here multitude of weights, we apply the graph theory. Similarly, even for this simple nodes and layers also graph theory, and for minimization optimization, that means operations research we use, and as usual probability. So first of all, probability will play the major role, later on optimization techniques, and finally the graph theory. Now, data science. Now here you could see different options, real world applications, scientific methods, and so on. Let me consider one example for this, our latest current problem, COVID-19. Here, COVID-19, it is a real problem, real life problem, global problem. So, for example, that problem has been given to one researcher or a scientist or an engineer. And here, because these are the data scientists, definitely their perspective is with respect to data analyzation part and the data consolidation only. So, first what they do, they take the problem and they check the scientific methods. Previous any scientific methods are there, existing methods are there, they check. If not, then what they do, they go for the data consulting. They approach the data consultation department of different areas, urban areas or rural areas, states, countries, districts, metropolitans, villages. Likewise, they'll collect the data. And after that, they go for the data research. So what kind of research they do? In metropolitan cities, what is the rate of the increase of this number of cases? Within how many days, how many cases have been arrived? And so this type of research would be done. Apart from that, just 1 minute. Hello. Hello. కొంచెం బిజీగా ఉన్నాను, తర్వాత చేస్తాను. Yeah, sorry. Yeah. After while doing this data research, so these people will be collecting the data from different areas and they will categorize that, and for every category they prepare the data charts, which is called as data visualization. And later on, after data visualization, like pie charts, bar graphs, or any other kind of data charts, and here especially they use also for this visualization. And then they come to statistical modeling. Once after completion of this part, they prepare a statistical model. And as already we discussed in the previous softwares, math related softwares, there itself we discussed about this part also, statistical computing. So what are the needs of the researcher or scientist or the engineer? Based on that, software itself will create the data which is definitely will be on par or to reach the expectations of these people. So after completion of this part, then we come to data technology. So what kind of software is to be used to get the proper results? Because we are not taking the data for 10 people or 20 people or 30 lakhs of people we are getting from different areas and different people. So lot of this. So naturally we go for a program. So which I have to be used for this. So maybe Python, or can I use R or any SPSS, or these kind of analysis will be there. And finally, they write the program and get the results and they come to some conclusions. So this is a general, very casual example I'm giving for this part, for this data science. And now we come to math and stat areas. What exactly? That means inner areas. What math areas are used for this data science? Under math category, linear algebra, calculus, and statistics category, descriptive statistics and inferential statistics. Again, what are the subcategories in this part? Under this linear algebra, linear equations, matrices, matrix decomposition, relations, computations, vector spaces, structures, and multilinear algebra, and so on. And similarly for calculus part, limits, differential calculus, integral equations, special functions, numbers, series, maxima, minima, and so on. Descriptive statistics, statistical analysis, univariate and bivariate analysis, inference statistics, statistical models. Like already once gave this example, like correlation, regression, and other hypothetical models, and so on. And statistical assumptions, appropriate distributions, approximation theory, randomization, and randomized experiments also. Now, once just go through this this one picture image, and here you could see one linear graph. So this is a linear curve, regression curve, and this XY axis are there. How to And first of all, let us see this part. This is the tabulation of the given statistical data, and then how to convert it into the model, and this is how to visualize that. And here if you observe matrices, and these are the statistical formulae, and this is the probability formula, and so on. All these are used for data science. Now come to one more very familiar and very interesting example for all of us. Math in social networks, maybe Facebook, maybe Instagram, or any other. Now here if you observe, here if you see along x-axis I'm taking Facebook friends, and along y-axis I'm taking time spent online, hours per week. And here this circle represents female people and this cross represents male. Now here these numbers are marked in this particular graph, and just by observing this graph we understood that this is not a linear one, which is a non-linear. And by using list, now come to another part. Math in curriculum and education, would like to focus a little more on this because a lot of tremendous importance is there nowadays. STEM is a curriculum based object on the idea of educating students in 4 specific disciplines: science, technology, engineering, and mathematics. Previously, even now also sometimes, all these areas are considered independently. So because of that reason, the student who opted sciences or technology or these areas, hello, some resound is coming. Excuse me. Yeah, fine. Science, technology, all these are the independent areas. These are treated, even now also we are treating in that way. But definitely an integrated or interdisciplinary approach has to be considered for relevant learning experiences for the students. See, a student who is opted for science may not be having a proper technological information or engineering expertise or math expertise also. Due to that reason, a student who takes any project, major or minor project, or any other internships or and so on, they are not performing well in that particular area. What is the reason behind that? The reason behind that is he is expertise in his area only, but not in other areas. So the student should have a basic knowledge even in other areas also. So the happiest thing is the recent national education policy. They are giving the opportunity to the students of selecting their own courses. That freedom has been given to the student. So one art student can pick up a math course, one science student can pick a math course, or art can pick a science course. Likewise, a lot of opportunities will be coming to the students in future. Now, actually knowledge, usually all of us usually consider education is knowledge. That is the reason why people are considering marks. How many marks you got, or what is your percentage, what is your CGPA or SGPA. So that based on that, people are assessing the student, but it is not correct. Why? Because knowledge means education, solutions, analysis, information, experience, and learning. All these together is considered as knowledge. So education is the part. Okay. So that is the reason why the students, they have to focus on interdisciplinary projects. Definitely tremendous applications or uses will be there in the next coming future careers of the students. Similarly, the internships. Now, once if the student takes the project, the student should not go for any copy paste work. They have to do the analysis part, assess that. Because of that reason, the student definitely will understand his strengths as well as the weaknesses in that particular area. If any weakness is there, automatically he can come out of that, and the strength is there, obviously he can strengthen his own strength. So similarly, internships also, if a student, the student usually thinks that 3 months I have to be in this particular company, within that 3 months, definitely if he show his performance well to that organization, obviously the student may be absorbed into that company, or the experience what he gains from that organization obviously will be useful to the next coming his placements or in the next employment. So definitely the students have to focus on these 2 areas. Now, in this part, we just consider higher order thinking also. Higher order thinking, definitely it is because as it is related to logical and reasoning thinking, definitely will be mapped with mathematics. The point is, there are three main types of intelligence and thinking. They are analytical and creative and practical. So, analytical thinking, definitely logic, reasoning, and aptitude building also. Creative. Nowadays, we people are hearing a word that is design thinking. And especially when I showed the slide related to mathematical modeling, they in the middle part research as well as brainstorming sessions. That brainstorming is nothing but the creative part only. So, what is our creativity? How we are mapping? How we are defining the variable? And what assumptions we are taking? So, all these are related to creativity and practical hands-on sessions. Lab taken to the class. All these are related to practicals or this one lab works. And we must understand them. Actually, the main concept is we need to understand the problem. We have to connect them to each other, categorize them, manipulate them, put them together in new or novel ways, and apply them as we seek new solutions to the new problem. So, all these we have to do to get the solutions for the problems. Specialized knowledge will not be covered during a math degree. Engineering internships and work experience can help if you want to improve your employability skills. This is every student has to consider this part. Now, specific fields, okay, specific mathematical topics which are very much useful in different areas or fields. First one I'm considering as game theory. Game theory definitely is used in decision theory, decision analysis, and interpretation. And usually, many organizations, almost every organization, people will be using either agile model or waterfall models. But like I prefer agile model because a lot of brainstorming sessions will be there, a lot of teamwork will be there. So definitely there would be I should say a genuine and a very good result output will be there. And the areas, in which area game theory will be used: economics, political science, biology, sports, engineering, electronics and communication, computer sciences, electrical engineering, and civil. Almost all the areas this game theory is used. Like I'm not reading all this because almost all the people are familiar about these areas. Now, the importance of discrete math in computer technology. Now, here you could see one Venn diagram. Actually, we are using this Venn diagram from our 7th or 8th standard onwards. But we never consider this as a mathematical model. This is a mathematical model. See, one real life problem, a general problem, it may be related to the university statistics or course statistics or marks or any other data would be given, a one-page data or half-page paragraph or a kind of data would be given to us. So immediately what we people do is if we convert into a Venn diagram without using any formula and all, simply this Venn diagram definitely will solve or will give the solutions for the unions or intersections or complements or differences and so on. So every solution will get from this Venn diagram, which is a mathematical model. And apart from this, the Boolean algebra and supporting software applications is a part of this discrete mathematics, and development such as converting problems of the real world to computer technology and creating algorithm. Everywhere we use discrete mathematics, especially Boolean algebra. And here you could see this gates like and, or, NAND, NOR, and so on. And here if you observe, discrete mathematics definitely is used in computer science subjects like data structures, design of algorithms and analysis, digital logic and design, artificial intelligence, network securities, computer graphics, and DBMS, database management systems, and so on, many also there. And what is the importance of 0 and 1? 0 and 1 play a tremendous role in computer technology. Without 0 and 1, there is no technology, I can say. Because see, this is the binary system. This is the starting point of that improvements or developments. Now here you could see the matrices with zeros and ones, like image processing, like dividing the main image into sub-images or matrices into sub-matrices and so on. Everywhere we apply this pattern. We use the 0 and 1 values. And vectors, trigonometry. What are the engineering applications? Mechanical, we use these two areas in mechanical engineering, civil engineering, EEE, and energy system engineering. So the internal concepts might be familiar to you, and especially the students who are studying these particular engineering areas definitely will have the clarity about this. Okay, so I don't want to focus much on this. Now, other common areas where math is a part: intelligent analysis, operations research, statistical research, logistics, financial analysis, market research, management consultancy, IT services, programming, public sectors, as a scientist or statistician, scientific research and development. So everywhere math is a part. And at least one example we have already discussed in the previous slides. And even few more examples will be coming in the next coming part. Now see, this is one more example, a real life example. Math breaks the code. Everyone knows this part. ATM card numbers, ATM pin numbers, generation of the pin, and other PAN card numbers or any other. Number theory is a part in which math is used for this. Number theory is a part not only for keeping the data secret, and for cracking codes also number theory is used. And this is a real life example: honeycomb. All of us know. A hexagonal structure, hexagonal cells will be there, even square shapes also there, even triangular structures also there in this. Now here if we see, it is difficult to get the honey out of their corners, and such kind of networking or structure is developed, connectivity is developed between the shapes. So that is the beauty of math. Now a few more examples. I just give a glance on these points. Rotational symmetry in globe, understanding the percentages, symmetry in tower, geometry in civil, and here you can see the shapes, structures, and here exact symmetry. Here the calculations, the measurements, XY values, three-dimensional values, all these will play a major role to construct this. Similarly, lines and planes, cubes, cones, parallelograms, all these are useful for the civil engineering constructions. Sphere and cube, pyramids, rectangles and circles. Now come to this geometry in CAD. Geometry is a part of math, all of us know. With questions of size, shape, and relative position of the figures and properties of the space and so on. And even nowadays, computer-aided design, AutoCAD. Geometric design representing the shapes, and here also a lot of math is used for the creation of the images and to instruct people or machines to build the shapes and so on. Structural engineering, in what way math is used. What shapes are rigid or flexible? How they respond to the forces and stresses, whether static or not, static or dynamic. And this is the essential geometry. So this geometry is used for structural engineering. Now come to computer graphics. A lot of math is used in computer graphics, like matrices, eigenvalues, eigenvectors, tensor analysis, vector analysis, and calculus. All these are used for this computer graphics. Even physics also plays a tremendous role for this, like optics and so on. And come to this robotics part, shapes, structure, measurements. For all these math is used. Math in medicine, medical images. For this, a lot of new geometry and other mathematics is also developed because of this. So a real life problem has come. To get the solution for it, a new math is also developed. So that is the beauty. So that is why I always say that general engineering or science or technology or anything and math are interrelated. Protein modeling. Using the geometry and related areas like combinatorics and topology, protein modeling will be there. And come to lossy compression. Here, compressed images and decompressed images. And for this, what math is used? See, construct n by n subimages for this matrices and transforms, Fourier transforms, all these, and inverse Fourier transforms. All these are used for coding and decoding. Now come to math in biology. Definitely symmetry. The major role which plays here is symmetry. Math in forensic, already one example we discussed. And what math is used here is the differential and integral calculus. And to get the clarity in the blur picture, we used to see in our TVs, sometimes a blur picture will be there and sometimes a face will be hidden with squares or rectangles or something. So for that, definitely eigenvalues and eigenvectors, they are used for this particular area. And math in music also, the other beauty is set theory, abstract algebra, number theory, golden ratios, and Fibonacci numbers. All these math areas are used for math therapy. Music therapy, music therapy. Now, air shock of atomic bomb. What is the structure after the blast? And the process of the explosion of first atomic bomb within first 1 second. After 0.006 seconds, what is the shape? After 0.026 seconds, what is the structure? Next, this is 0.016 and this is 0.025. What is the shape? And after 0.053 seconds. So within a second, they have taken all these pictures with the help of math. So, and here the internal characteristics used are air density, pressure, force, length, and so on. And come to another part, image recognition, reconstruction of computer tomography. And here what math is used. You can observe the parametric equations and straight line parametric equations as well as the integrations, integral equations. Come to another one, CT technology. This is a combination of physics and math only. You could observe exponential curve, exponential equation we are using e to the power of, and similarly one integration, and similarly trigonometric values, matrices, all these are used to get the solution for this part. Now come to math in labs. Previously, math is considered as a theoretical subject. Later on, identified that math is not exclusive theoretical course. It is embedded with lab also. After identifying that, then later stages, some lab practicals also have been started in some universities by using like Maple or MATLAB or any other Mathematica, and so on. Fine. So math, combining the mathematical modeling, numerical analysis, simulations. See, all these simulations are lab parts only. Visualization, trial and error method also will be applied for the simulations as well as visualizations. So this is a tool in the most diverse fields like communications, industry, engineering, and so on. So because of this, whenever we start a practical application, definitely it will be useful to the society. Because of that reason, lot of interest has been developed, and these applications leads to the establishment of the big institutes or tremendous improvement in the computational biology also. Math, it satisfies all the individual needs, organization needs, business, as well as national needs and universal needs. This point we need to consider a lot. Now come to math in defense sectors. How math is used in defense sectors. Cutting edge mathematics and statistics lie behind smart sensors and advanced control and communications. This is the math application in defense sector. Similarly, the mathematical sciences are used in planning logistics, deployments, and scenarios evaluations for complex operations. In defense sectors, a lot of complex operations will be there, lot of security and privacy. All these areas also they need to consider. So for all those, even for the technology related issues also, these mathematical sciences are used. Come to other areas, mathematical simulations allow predictions of the spread of smoke to how much area it will spread, how many kilometers, what would be the effect calculations. All these will be done by using mathematical simulations. So math is used to design advanced armor. This is another application which is used in defense sector. Math and stat underpin tools for control and communications in tactical operations. See, especially nowadays, Facebook, Twitter, Instagram, and so on. Social networks. Cyber crimes, lot of cyber crimes are increased, and similarly, this banking related also. Lot of issues are there because of this sharing the data in the social networks. Even that also, to resolve all those problems also, math and statistics will be used. Now, we have discussed a lot of small applications or importance of the math in different fields, and finally we consolidate the area of the application in the real world and what math field is used in this particular application. Now, banking sectors for banking transactions, emails, and ticket reservations, what math is used? Theoretical computational math for automata theory and formal languages. And finite differences, finite elements, which comes under the area fluid mechanics. And which math is used? Differential and integral equations of computational mathematics. Most of us are aware of this part. Um, Telephone networks, parallel connections for phone, gas, electricity, and so on. And for this, discrete math, graph theory, and with its applications. And here, this part, if like I'm just recalling that driverless car, self-driving car. Even there also, they consider these parallel connections only, parallel connections, and recognizing the video images. For that also, these two areas are helpful. Mechanics of solids and fluids in zero gravity. What is the math in that? Stability analysis, chaos theory as dynamic systems, theory of fluids, under that category, complexity models, stochastic climate modeling. And one more very important and interesting area is stochastic modeling, stochastic process. This plays a tremendous role in the latest developments with respect to science or engineering or technology. And aeronautics, hydrodynamic problems. Here we use hyperbolic equations, boundary layer problems, traveling waves, and so on. Modern physics, geophysics, seismic phenomena, material science, nanotechnology. These are the another very important science areas in the real world. Now, what math is used in this? Group theory, all of us are familiar about it, topology, tensor analysis, and so on. So I'm just reading the well-known concepts. Now here, partial differential equations for geoscience and free boundary problems also, boundary layer problems or boundary problems and so on. Seismic phenomena, wave propagations and inverse problems. And material science, linear, non-linear elasticity, calculus of variation, and homogenization theory also. Now come to nanotechnology part, quantum states, semi-classical Boltzmann equations. These are used for nanotechnology. Now come to engineering part, electrical engineering and subcategory of the engineering area as well as math. Resistors, inductors, capacitors and power engineering. Analysis of electromagnetic fields. These electromagnetic fields, one example already we discussed in the beginning part, and their interactions with the materials and structures. Similarly, logical gates, this is the math part, logical gates and Boolean algebra. Electronics engineering, digital signal processing, image processing, and math areas, Fourier series, transforms, and RC circuits, and so on. Mechanical and civil engineering, fluid flows, stress analysis, mechanics, differential equations. Math parts are differential equations, integration, geometry, calculus, and linear algebra, etc. Now here, come to computer science, a lot of things we have discussed like linear algebra, probability, statistics, calculus, cryptography, number theory, regression analysis, correlation, discrete math, and so on. Industry engineering, fluids, aerodynamics, materials, and fracture theory. Once fluid is there, automatically all these will come into picture like differential equations, integral calculus, vectors, all these will come into picture. Now, come to this biomedical engineering. Because of this COVID, usually because of this part, we will consider before COVID as well as after COVID. Such kind of enormous changes have come into social life. For this, what math is used? Mathematical modeling and analysis of biomedical problems. Already one example we discussed, CT scan, and numerical analysis for biomedical sciences and biomedical engineering. This also one more example, traumas and all we discussed. Optimization techniques and computational methods for biomedical applications. So here, actually optimization techniques means a lot of operations research problems we can discuss, but may not be related to the biomedical. I just brief out, like inventory problems, like transportation problems, job sequencing problems, estimations, all these will come under optimization techniques. Mathematical models for electromagnetic bio-optics and neural engineering. Here this mathematical model with bio-optics will be used in every latest development or any creation of any machine or anything. Next, inverse problems in biomedical imaging, including image reconstruction algorithms, methods for biomedical image processing and visualization, computational methods for physiological signal processing. Again, we are using the word signal processing. So the engineering part also will be engineering as well as math as well as biology. All together, all these people together can solve the problem and get the solution. Now, I request the faculty fraternity that while preparing the question paper, please don't ask the questions like solve the following problem. Again, write the solution for this problem. So because of that reason, the student will be thinking in a perspective that fine, okay, if I see the problem and if I get the solution, or if I remember the formula and get the solution, that's more than enough for me to get the marks in the exam. But that is not useful in the current scenarios. The reason behind that is a lot of math has been developed long back. So, and even the software is also there. If I want a solution for a particular math problem, definitely I can use either MATLAB or Mathematica or any other software. All these are available in the market now. So I don't want a solution. Solution automatically I can get by using my any even languages also like Python, C or anything. So that is not the math perspective. So what is the basic requirement? The basic requirement is analysis. And every student definitely should have a clarity on the work what he is doing. If he reads a problem, he has to understand what exactly the meaning of the problem and what is the definition of the problem, what variables I can generate, what are my assumptions and what brainstorming sessions I have to, and what research related to that problem I have to. So if that such kind of clarity is there, definitely the perspective towards mathematics definitely will be changed. Because of this perspective is missing, or this counseling or any other like what to say approach is missing, because of that reason some students really fear about mathematics. The students may think that lot of solving part will be there. I have to remember a lot of equations. I have to do lot of calculus part. So this is the general perspective. Because of that, the beauty, the essence, the flavor is missing from mathematics area. So this is my humble request for all mathematicians. Now, fine. What is the reward of doing math? Use all of your skills and talent to solve the problems of the world. Yeah, fine. Thank you so much for sparing your valuable time, all of you. And once again, I thank the management of Vignan and organizers, HOD, principal, all. Once again, I thank you all. Now, we come to the questions session. Any questions related to that? Yeah.
Any questions from the participant then?
Yeah, just wait, madam. I got one question from YouTube. How to use mathematical model to develop the CWDN?
CWDN means can they give the abbreviation for that? Because that might be some engineering area.
Actually, I
okay.
See,
fine, no problem. Fine, no problem. See, any engineering part, anything. The starting mathematical modeling will be the common part. Problem might be changed, right? The application problem will be changed, but the sequential steps will be the same. First of all, identification of the problem and identification of the variables and defining it, okay, assumptions and so on. This is the general mathematical modeling. Any problem, whatever the problem you take, maybe variable may be changed, maybe assumption may be changed, right? Structure will be the same. Hello?
Yeah, madam. Yeah, madam.
Yeah.
Still, any questions from the participants? As we are running short with the time. Okay. So let us end this program here. Ma'am, thank you so much for being with us and sharing all the latest related techniques related with the mathematics and with the importance of maths and how well the technology, along with technology, how the mathematics has been used. Thank you so much for sharing all the valuable information, ma'am. And thank you for accepting our invitation. And I thank once again all the participants for being participated in this webinar. And as soon as you all complete the feedback link, immediately you'll be receiving the certificate, participation certificate. Thank you all. Thank you, ma'am.
Thank you all. Thank you. Bye.
Bye, ma'am.
Thank you, ma'am.
Bye, ma'am.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you all.